Hello everyone, my name is Martin Gillespie, and in this presentation I'll be talking about the igneous rocks of Singapore. Now the information I'll be presenting is based on work done by the British Geological Survey between 2016 and 2018 as part of the BCA Deep Ground Investigation Programme. That work is described in detail in this recently published memoir, which covers all aspects of the geology of Singapore. And there's also now a paper focusing specifically on the igneous rocks of Singapore that was published recently in the Journal of Asian Earth Sciences. So if you're really interested in the igneous rocks and you want to find out a bit more about them, I suggest you take a look at these two documents. So here's what I'll be covering in this presentation. We're going to look at all the igneous rocks of Singapore, so that's the main intrusions and also the main units of pyroclastic rocks. I'll describe where they occur, how we've organised them in the new geological framework for Singapore. I'll summarise what we know about their age and lithological character, and I'll show what they look like and describe some of the things that can help you to identify them in cores and outcrops. Now, I won't have time to talk about the regional setting of the igneous rocks and their petrogenesis. These topics were covered briefly in an earlier presentation, and as I've just mentioned, if you're interested in finding out more about the regional setting and the petrogenesis, there's plenty of information in the new geological memoir and in a recent paper in the Journal of Asian Earth Sciences. So we'll start with the picture across Singapore as a whole. This is the new map of the bedrock geology in Singapore. And as I'm sure you already know, virtually all of the ground on the northeast side of the Bukit Timah fault zone is underlain by intrusive igneous rocks. Now that's nearly 2/3 of the land area of Singapore, so these rocks are a very important part of Singapore geology. And by contrast, the pyroclastic rocks, so these are deposits formed by explosive volcanic eruptions. They're much less widespread, but they are important locally, particularly here to the southwest of the Bukit Timah fault zone, where they form discrete layers in the strata of the Jurong group. And then there's a separate isolated unit over here on Pulau Tikong. So we'll focus on the intrusions to begin with, and I'll start by describing how the new intrusions that we've identified are distributed and how we've assigned names to them. And I'll show you how we've constructed a geological framework to demonstrate how those intrusions relate to each other. Now, previously, only one small intrusion was mapped in Singapore, the Gombak intrusion, which is highlighted here. And although the rest of this ground was known to consist of granitic rocks, it was undivided. In other words, no discrete intrusions were mapped within it, and this whole area was referred to as the Bukit Timah Granite, or sometimes the Central Singapore Granite. But on the new map, you can see this ground is now divided into a number of coloured polygons, each of which indicates a different bedrock unit. And in fact, we now recognise 6 major intrusions in this ground, each one highlighted here with a yellow cross. So here are those new map polygons in a bit more detail. They're more brightly coloured here, so you can see the 6 main intrusions more easily. And these coloured dots on the map indicate the positions of boreholes that were drilled as part of the BCA Deep Ground Investigation Programme. And most of the information that we've used to characterise the different intrusions in this area is based on the drill cores from these boreholes, because the bedrock is generally very poorly exposed across the whole area. Now you can see that the boreholes are concentrated in the west of this area. There are none in the east, so I would say that the map there's more confidence in how the map is drawn in the west than there is in the east of this area. However, there is plenty of outcrop in the northeast, on Pulau Ubin and on the north coast of mainland Singapore. So the map here is based on field observations, and the dots in this area mark the positions of some of our field stations. And by carefully examining all of the cores and the outcrops, and by using a suite of laboratory tests on a lot of rock samples, we've been able to show that the rock underlying each of these coloured polygons is distinct in terms of its lithology, its geochemical character, and its age. So we're very confident that each polygon on the map represents a different intrusion. Now we've given each intrusion a name, and you'll see that the formal version of each name has three components. There's a term to indicate the type area, so for example Simpang. There's a term to indicate the lithological character of the intrusion, so for example Granite. And there's a term to indicate what type of intrusion it is. Now we've classified all of the intrusions as Plutons, which simply indicates that each one is pretty large and has a poorly defined shape. So a full formal name like Simpang Granite Pluton and Gombak Gabbro Granite Pluton has three components in it, but these names can be pretty long and cumbersome, so you can abbreviate them to something shorter like Simpang Pluton or Gombak Pluton for convenience. Now we've dated all of the Plutons using uranium-lead geochronology, and that has allowed us to create a geological framework for the Singapore intrusions. So this is the framework, with the intrusions arranged from the oldest at the bottom to the youngest at the top. And from the dating work we've done, we know that the 5 oldest Plutons were emplaced over a time span of around 55 million years, starting in the Permian period and finishing in the Triassic period. And we think that these 5 Plutons are related. They all formed within the Sukhothai arc, which I think was mentioned in an earlier presentation of this seminar. So in the framework, they're grouped within a single parent unit, which we've called the Bukit Timah Center. And so you can see that the Bukit Timah Center straddles all of the main intrusions across the main part of Singapore. And that term, Bukit Timah Center, allows us to refer to all 5 of those Plutons collectively. Now the Bukit Timah Center would have been larger than this originally, but some of it has probably been cut off along the Bukit Timah fault zone, and currently we don't know how far it extends either north into Johor or south towards Indonesia. Now the youngest unit, the Pulau Sekudu quartz monzonite Pluton, is a relatively small intrusion that crops out up here on and near to the south coast of Pulau Ubin. And this Pluton is Cretaceous, so it's a lot younger than the Bukit Timah Center and not related to it. And there's one other unit in the framework which I haven't mentioned yet, the Singapore Basalt Andesite Dike Swarm. As the name suggests, this unit consists of lots of basalt and andesite dikes, but they're not shown on the map because individually they're too small. Nearly all of them are less than about 2 meters thick. But you do see them quite commonly in outcrops and cores. So they're classified together as a dike swarm, and that's put in the framework as a discrete unit. We haven't been able to date the dikes using uranium lead. We have looked for zircon in the rocks, but we haven't found any zircon there, so we haven't been able to date them. But they do cut all of the Plutons with the Bukit Timah Center. And there are similar dikes in Malaysia with published dates that suggest they were in place sometime between the Upper Triassic and the Lower Cretaceous. So on that basis, the Singapore Basalt Andesite Dike Swarm is fitted into the framework here between the Bukit Timah Center and the Pulau Sekudu Pluton. Okay, so we'll move on now to talk about the geological character of the intrusions, and specifically what the rocks in each Pluton look like and how to recognize them. Now, it would be nice if the rocks in each Pluton had a distinctive character that was consistent everywhere and made it easy to tell them apart from each other. But unfortunately that's not the case. In fact, it can be quite challenging to distinguish the rocks in each intrusion for two reasons. Firstly, most of the plutons are formed of granitic rock, so that means they're either true granite or they're a very similar rock type. So they tend to be coarse-grained, formed of the same minerals, and broadly similar colour in an unaltered state. So that means they can look pretty similar if you don't know what to look for. And secondly, the rocks within each pluton are not homogeneous. In fact, they're often quite heterogeneous because each pluton tends to have quite a complex history. So for example, processes like magma mingling and magma quenching clearly operated as some of the plutons were being emplaced. And processes like deformation and hydrothermal alteration affected some of the plutons after they were emplaced. So the visual character of the rocks in each pluton can vary from place to place, and sometimes that can happen within the same core or the same outcrop. So it's important to be aware of not just what the main rock type is in each pluton and what that main rock type looks like, but also what range of lithologies and textural features you might see, and what the most distinctive or diagnostic features of each pluton are. And I'll just remind you of the resources that are available now to help you identify which pluton you're looking at. There's the new bedrock geology map of Singapore, and obviously if you can locate the position of your borehole or outcrop on the map, then the map will indicate which pluton you are in according to our current understanding of the bedrock geology. But do remember, as I said previously, that there is some uncertainty about where the pluton boundaries are in the eastern part of the map, where the outcrop is very poor and we don't have good borehole coverage. So you shouldn't assume that the map is currently correct everywhere. There are full descriptions of each pluton in the new memoir, and there are summary descriptions in the new practitioner's guide and in the Journal of Asian Earth Science paper that I mentioned earlier. And in all of these documents you'll find photographs of the typical rocks and of the diagnostic features. And finally, don't forget to look at the stratotypes. And just to remind you, a stratotype is either a borehole core or a particular outcrop that we've identified as the reference standard for each bedrock unit in the geological framework for Singapore. So the stratotype for a particular pluton will contain good examples of the typical rocks and other features that you might see in that pluton. There are details of all the stratotypes in the memoir and in the practitioner's guide, and I think you can arrange to see them by contacting BCA. So I'm going to summarise some of the key features of each pluton now, and we'll start with the oldest one, which is the Cho Chu Kang Pluton. So we've managed to date the Cho Chu Kang Pluton very precisely. It's 285 million years old, which is Permian, and that makes it the oldest intrusion in Singapore. And the first thing to point out is that there are 3 separate polygons on the map. The main one here forms a long and quite thin outcrop on the northeast side of the Bukit Timah fault zone. But there are 2 other small polygons in the north part of Singapore, one here and another one here, where we found rocks that have the same character and the same age as those in the main outcrop in borehole cores. And we think this means that the original Pluton must have been much bigger and was broken up or dismembered when these younger Plutons, the Dairy Farm Pluton and the Simpang Pluton, were emplaced. So it's worth bearing in mind that there may be other bits of the Cho Chu Kang Pluton elsewhere within the outcrop of the Bukit Timah centre, possibly in the Dairy Farm Pluton and possibly also in the more bits in the Simpang Pluton, in areas that we haven't examined in detail yet. Now this is the only Pluton in which we found xenoliths of sedimentary rock. We found them in 2 areas so far, down here and again up here in the Pungal district. I don't have a photograph, unfortunately, but they're blocks of grey, quite glassy looking metamorphosed sandstone that you find enclosed in the igneous rocks of the Cho Chu Kang Pluton. They're certainly up to a few metres across, and possibly quite a lot bigger than that in some places. And we think these xenoliths are derived from the Sajahat Formation, because that formation is carboniferous. It's the oldest bedrock unit in Singapore, and so it was probably the country rock when the Cho Chu Kang Pluton was emplaced. Now, we've only seen these xenoliths in two places, so they're quite rare, but so far this is the only Pluton in which we've seen them, so they're diagnostic. In other words, if you see grey metasandstone xenoliths enclosed in granitic rocks, you could be fairly confident that you're in the Cho Chu Kang Pluton. And the stratotype for this Pluton is BCA borehole 1B9, which is here. So this is the core that we've selected as the reference standard because we think it's got the best examples of the Cho Chu Kang rocks in it. So here are some examples of what the Cho Chu Kang Pluton looks like in core. Now I've got quite a lot of photographs of core in the rest of this presentation, and I should just say that they're all cores from the BCA Deep Ground Investigation Programme, and in each photograph the core is about 6 centimetres wide in this dimension. Okay, so 6 centimetres there, just to give you an approximate scale. So the rock is, generally speaking, it's grey, coarse-grained granodiorite grading to tonalite. So it's very like granite, but it's not actually granite because it has more plagioclase feldspar than alkali feldspar. And it's the only Pluton in Singapore that is formed of granodiorite and tonalite, so that is a diagnostic feature. It's also the only Pluton in which a lot of the rock is deformed, so that's another diagnostic feature. But the intensity of the deformation varies quite a lot from place to place. So for example, this is what the rock looks like when it's nearly undeformed. It has a fairly typical appearance of a coarse-grained granitic rock. But in this example, the rock is deformed and the deformation has produced quite an intense foliation in this orientation. However, in this example, the rock is also deformed, but it's produced quite a strong lineation. You can see that the individual grains are elongated and aligned in a vertical orientation. So this whole rock has been stretched by a process of deformation. And here's an example where the deformation has been so intense that it's produced a myelinite fabric. We've only seen this in one core, but in that core, rocks with this intense degree of deformation occupied a zone that was up to 17 meters thick, so it was a substantial zone of intensely deformed rock, and there may be other similar zones of myelinitic rock elsewhere within the outcrop of the Cho Chu Kang Pluton. And finally, the rock next to the Bukit Timah fault zone can be strongly altered as well as being deformed. So this example is still granodiorite, but the feldspars and the biotite in the rock have been replaced by hematite, and that gives the rock quite a strong reddish-brown colour. So to begin with, it looks nothing like the Cho Chu Kang Pluton, but it is the Cho Chu Kang Pluton. It's just in a very altered state next to the Bukit Timah fault zone. So all of these examples are granodiorite grading to tonalite, but you can see there's actually quite a lot of visual variability in different parts of this Pluton. Now we'll move on to the Gombak Pluton. This is the second oldest Pluton in Singapore, and by far the smallest in the Bukit Timah Centre. However, although it's small, the uranium-lead ages for this Pluton range from 260 to 245 million years. So it seems to have been assembled over a period of at least 15 million years. And perhaps because of that long magmatic history, it's also lithologically complex. So the central part of the Pluton in here seems to be mainly massive homogeneous gabbroic rocks. But close to the southern edge of the Pluton down here, there's a body of layered gabbro, and most of the northern part of the Pluton seems to be dominated by very heterogeneous rocks that formed by mingling and mixing of gabbroic and granitic magmas. There are also some discrete sheets of granite that cut earlier rocks in the Pluton. So the term gabbro granite that we've used in the formal name reflects this pretty wide lithological range. Now the main stratotype for the Gombak Pluton is borehole BCA borehole 1B8, which is here. So this has got massive gabbro and also lots of the very heterogeneous rocks that form by magma mingling and mixing. But borehole 1E2 here is also identified as a reference core specifically for the body of layered gabbro. And before we leave the map, I'll just point out that there's another quite large body of gabbroic rocks further to the north, next to the Nisun Fault. And these look quite like the gabbroic rocks in the Gombak Pluton. Now we don't know much about this body, but it might be the same age as the Gombak Pluton, or it might represent a large body of basic magma that was mingled in the magma of the dairy farm Pluton. We'd need to date the rocks to find out for sure, and that hasn't been done yet. But the fact that this quite large body of basic rocks has been identified raises the possibility that there are other similar bodies in other parts of the Bukit Timah Centre that haven't yet been identified. So here are some examples of what the Gombak Pluton looks like in core. The massive gabbroic rock, which you can see in the central part of the Pluton, is formed of coarse-grained black and white crystals of pyroxene and plagioclase, and it's generally homogeneous. The layered body at the south edge of the Pluton has two types of rock that occur in alternating layers, and each of these layers is up to 9 meters thick. So one type of layer consists of equigranular gabbro, in which all the crystals are a similar size, and this rock looks quite similar to the massive gabbroic rock that occurs outside the layered body. The other type of layer is inequigranular gabbro, in which the crystals range from very coarse-grained, you can see some up here, to fine-grained. And this texture, this is actually more like a pegmatite texture than a normal gabbroic rock. And finally, here's an example of rock produced by mingling and mixing of a siliceous magma, which is now the pale component, and a basic magma, which is now the dark component. And the two magmas have mingled here, and down here they've interacted more to an extent that they are mixed. So this example gives you a sense of how incredibly heterogeneous in character these rocks that form by magma mingling and mixing can be. So the rocks of the Gombak Pluton, they're really very distinctive lithologically, and of course they occur within a small and well-defined area. So they shouldn't really be confused with the rocks in any other Pluton in Singapore. Now, the dairy farm Pluton, this one is interesting because the whole Pluton is of monzogranite composition, which means it's a type of granite with approximately equal proportions of alkali feldspar and plagioclase feldspar. But there are two distinct textural variants in different parts of the Pluton. So you can see that it's divided into two parts on the map. This slightly larger eastern part consists of rocks with an equigranular texture, which we've called facies 1. And the smaller western part consists of rocks with a distinctly inequigranular texture, which we've called facies 2. And there are quite a lot of BCA boreholes in this area. All the red dots that you can see are BCA boreholes. So the positions of the boundaries around this Pluton and the boundary between the two facies are probably quite well constrained in this case. Now the uranium-lead dates for this Pluton show that it was emplaced over a period of around 5 million years, between about 244 and 239 million years ago. So it began to be emplaced immediately after the Gombak Pluton stopped being emplaced. In other words, this was the next phase of activity in the Bukit-Timah Center. And the stratotype for this Pluton is BCA borehole 1B11, which is here. And although it's cited in the part of the map that is assigned to Facies 2, this borehole actually has good examples of both Facies 1 and Facies 2 in it. Okay, so what do the rocks look like? Well, here's an example of Facies 1 in core. You can see that it's a typical grey granite with quite a distinctive speckled appearance produced by evenly distributed black and white minerals, what you might call a salt and pepper character. And you can also see that the crystals are equigranular. In other words, they're all of a broadly similar size, with no phenocrysts and no ground mass or matrix. And then here's Facies 2. So it has the same minerals as Facies 1 and the same composition overall, but you can see that it's a bit darker and it has a different texture. It's got an inequigranular texture with larger crystals or phenocrysts enclosed within a finer grained matrix or ground mass of the same minerals. So this is really a porphyritic texture, and you can see the difference between the two facies quite clearly in these thin section photographs which come from the same bits of core. Now the alkali feldspar is coloured yellow in these thin sections, which is why they look a bit odd. But the equigranular texture of Facies 1 is obvious here, while the inequigranular texture of Facies 1 is very obvious here. You can see the phenocrysts very clearly, large crystals of quartz and feldspar, and in between a ground mass or a matrix of much smaller crystals of the same minerals. And our interpretation is that the porphyritic texture in Facies 2 developed when the slowly cooling magma suddenly crystallized very rapidly. In other words, it was quenched. And that was probably due to a sudden drop in pressure when the magma chamber either vented gas or erupted. And we'll be coming back to that point a bit later on. Now we'll move on to the Pulau Ubin Pluton. This one seems to have been emplaced around 242 million years ago, which means it's essentially the same age as the Dairy Farm Pluton. Now on the map we've inferred that the Pluton underlies all of the eastern part of mainland Singapore. But as I mentioned earlier, there are no BCA boreholes in the area, and a lot of the bedrock here is hidden beneath younger sedimentary rocks. So it's important to be aware that we don't know for certain that the Pulau Ubin Pluton underlies all of this ground, and it's possible that there are other intrusions in parts of this area. Now this oval outline on the map is the Pulau Sekudu Pluton, which I'll talk about shortly. But this one is younger than the Pulau Ubin Pluton, and when it was emplaced, the intense heat produced a thermal aureole in the Pulau Ubin granite. In other words, it metamorphosed the Pulau Ubin granite that was immediately adjacent to it. And the most intensely affected rocks, which are probably in a zone no more than a few tens of meters wide, they no longer look like granite. They've really become a glassy looking hornfels. And this pattern of white stipples on the map, you can see here, shows our interpretation of how far we think the full effects of metamorphism extend. So the most intensely metamorphosed rocks are just in a very thin zone next to the contact, but rocks probably for a kilometre or two away from the contact will show some degree of effect from this thermal metamorphism. Now that we've just shown this pattern of stipples in the onshore parts of the map, but the metamorphism probably extends into the offshore ground as well, right the way around the Pulau Pluton. So the stratotype for the Pulau Ubin Pluton is on the north coast of mainland Singapore, just here. It's a coastal exposure, and the rock here is typical granite of the Pulau Ubin Pluton. It doesn't seem to have been affected by the thermal metamorphism. So what do the rocks look like? Well, the main rock type is pale grey Monzo granite with a sort of a speckled character, a bit like Facies 1 of the dairy farm Pluton. It's usually more or less equigranular, but quite commonly you see evidence of inequigranular texture. So that might be, you might see rocks with some phenocrysts, or rocks that have got a finer grained ground mass. So there is some similarity with Facies 2 of the dairy farm Pluton, but a proper sort of quenched character isn't as well developed in this Pluton as it is in the dairy farm Pluton. And we don't yet have enough information to say whether you can map discrete areas of equigranular and inequigranular rocks in the Pulau Ubin Pluton in the same way that you can in the dairy farm Pluton. Now, another fairly common feature in the Pulau Ubin Pluton are things called myrolitic cavities. Here's a photograph of some typical ones. Now, these were originally pockets of gas in the magma, and they're now cavities in the rock that are lined with euhedral crystals. And these ones in the Pulau Ubin Pluton, they can be up to several centimeters in diameter, like this example here. And they tend to be clustered together in local concentrations. So you might see an outcrop that's got a number of these things in it, and then the surrounding rock might have none of them in it. So they're quite localized. They don't occur everywhere. And magma mingling is a common feature in this Pluton. This photo is on the south coast of the island of Pulau Ubin, and you can see large rounded bodies of dark mafic rock enclosed in pale granitic rocks. This is classic magma mingling texture. And this sort of thing seems to be widespread in the Pulau Ubin Pluton. You see it in a lot of coastal exposures and old quarry faces, that sort of thing. In fact, there are some spectacular photos of old quarries on Pulau Ubin with magma mingling textures covering huge faces of rock. Okay, now we'll look at the Simpang Pluton, which at 231 million years old is the youngest Pluton in the Bukit Timah Center. So in other words, this Pluton marked the last phase of magmatism in this part of the Sukhothai Arc. Now on the map, it's shown to be the largest of the Plutons in Singapore, underlying this broad swathe of ground that extends through the centre of the island all the way from the north coast to the south coast. But again, you should be aware that there's some uncertainty about the extent of the Simpang Pluton, particularly in the central and south parts of the map, because there are no BCA boreholes here and most of the bedrock is hidden beneath sedimentary rocks. Now the stratotype is here BCA borehole 1C6, which contains good examples of the main rock types in the Pluton. So here are some examples of core from the Simpang Pluton. Now the main rock type in the Pluton is cyanogranite, which is a type of granite that has more alkali feldspar than plagioclase. And the Simpang Pluton is the only intrusion in Singapore with that composition. And as you can see in these photographs, there's quite a lot of textural variability. So the rock can be equigranular or nearly equigranular, as in these two examples. And in some cases it can be quite strongly porphyritic, as in this example. Evidence of magma mingling is quite common. Typically you see bodies of dark mafic rock enclosed in pale granitic rock, just like this, but it occurs on a range of scales. The bodies of dark rock can be centimetre scale, as they are here, but they can be up to 10 metre scale in some of the cores that we've seen. Now, hydrothermal alteration is also quite a common feature in this Pluton. So whereas the unaltered rock is pale grey, most of the rock is actually mildly to quite strongly altered. And it's quite common for the rock to have a pale yellow tone, like it is in this example and in this example. And you also see it in places where it has a pink to orange tone, as it is in these two examples. And the hydrothermal alteration has mainly affected crystals of alkali feldspar. So because this is a relatively alkali feldspar rich rock, the effect of hydrothermal alteration is perhaps a little more obvious than it normally would be. So that's all the Plutons in the Bukit Timah Centre, but there's one more to talk about, the Pulau Sekudu Pluton. Now, I've already mentioned this one. At 98 million years old, it's Cretaceous, and it's the youngest Pluton in Singapore, and clearly not related to the Bukit Timah Centre. This is it here, this dashed outline on the map. And again, there are no BCA boreholes in the area, but there are good exposures along the south coast of Pulau Ubin, and on the tiny island of Pulau Sekudu, just here, from which the Pluton gets its name. But most of the outcrop is offshore. Now, the shape of the outcrop is poorly constrained, but we've inferred that it's a roughly east-west trending ellipse based on the exposure on Pulau Ubin and the fact that it doesn't crop out on the Singapore mainland. Now, the stratotype is at the east end of Pulau Sekudu, where there are some superb core stone exposures at low tide, but you need a small boat to get there before you can see them, so there are reference exposures along the coast on the south side of Pulau Ubin. So here's what the rock looks like. These are the fantastic core stone exposures on Pulau Sekudu. And this is one of the exposures on the south coast of Pulau Ubin. Not a very natural one, but it's a good exposure nonetheless. Now, the rock looks quite granite-like, and it has exactly the same minerals that you find in the granitic Plutons of the Bukit Timah Centre, but it actually doesn't have quite enough quartz to classify as granite. So it's actually a rock type called quartz monzonite, and it's the only Pluton of that composition in Singapore. So again, the rock composition is a diagnostic feature of this Pluton. Now, the rock is also notably very fresh. There's none of the hydrothermal alteration that you see in the Bukit Timah Centre rocks. And the rock on Pulau Sekudu is noticeably coarser grained than the rock on Pulau Ubin, presumably because the Pulau Ubin exposures were closer to the Pluton boundary, where the magma would have cooled more quickly. And perhaps the most distinctive thing about this Pluton is that there are lots of mafic enclaves in the rock. So these sort of rounded and often elongate little dark bodies of basic rock are very common. They're scattered quite evenly through the Pluton, and as I say, they're a very distinctive feature. They're effectively a product of magma mingling, but unlike the Bukit Timah Centre Plutons, where magma mingling tends to occur within specific parts of the Pluton, in this case, these little mafic enclaves seem to be scattered more or less evenly throughout the whole of the Pulau Sekudu Pluton. Okay, that's all I'm going to say about the intrusions. So we'll finish with a quick look at the pyroclastic rocks of Singapore. So these rocks are the products of big volcanic eruptions, and they occur now as discrete layers within the sedimentary strata. And there are 4 layers of pyroclastic rock that are thick enough to be classified as distinct units and given formal names of their own. So this is how they're distributed at outcrop. The Pengerang Formation crops out up here on Pulau Tikong, and this deposit has been linked to one of the big Triassic volcanoes to the north in Johor, somewhere to the north of here. The rock is probably mainly lapilli tuff, but it's very poorly exposed and very weathered, and BGS geologists actually haven't seen any examples of it, so unfortunately I'm not going to be able to say any more about this unit just now. The 3 other units all occur to the southwest of the Bukit Timah fault zone within the strata of the Jurong group. So the Clementi Member crops out in a narrow swathe of ground that's close to and parallel to the Bukit Timah fault zone. The Kent Ridge Member crops out a bit further from the fault, around about here. But we know from boreholes that it continues along strike in the subsurface, at least as far as here. So the unit is at least 10 kilometers long. And finally, as far as we know, the Nanyang Member crops out in just a small area around Nanyang Technical University here. But from cores, we know that it extends underground across quite a large area to the south of the university site. Now, you do find other layers of pyroclastic rocks in other parts of the Jurong group strata, but they're too thin to classify as discrete units, and these 4 are the only ones that are thick enough to be classified separately. So we'll look now at the stratigraphical position of the pyroclastic rock units. And here's where they sit within the new lithostratigraphical framework for Singapore. Here's the Jurong group towards the base of the framework. And I've expanded it here to show the detail within it. And you can see that 3 of the pyroclastic rock units are classified as members in different formations of the Jurong group. So the Clementi Member is a part of the Boonlay Formation. The Kent Ridge Member is a part of the Pandan Formation. And the Nanyang Member is a part of the Pulau Air Chawan Formation. Incidentally, the Pengerang Formation is included here to show that it has exactly the same uranium-lead age as the Clementi Member. So the 2 are contemporaneous. But the Pengerang Formation is technically not part of the Jurong group because it wasn't deposited in the Sementan Basin, which the Jurong group was. Now, actually, all of these pyroclastic units have produced essentially the same uranium-lead age of about 242 plus or minus 3 million years. So the fact that they sit within different formations of the Jurong group indicates that the Jurong group strata must have been accumulating rapidly at that time. And that date of 242, which is Middle Triassic, coincides precisely with the age of 2 Plutons in the Bukit Timah Centre. If you remember, the Dairy Farm Pluton and the Pulau Ubin Pluton both provided a uranium-lead age of 242 million years. So this was obviously a really dynamic period in the development of the Sukhothai Arc. It was probably the peak of magmatic activity in this part of the arc, and also a time when sedimentary and pyroclastic strata were accumulating rapidly in the Forearc Basin. So we'll take a quick look at what each of these pyroclastic units looks like in core. And the good news is that they're all quite different and easy to tell apart. So we'll start with the Nanyang Member, which is the oldest of the pyroclastic rock units. It's at least 56 meters thick at its thickest point, and it consists of multiple layers, each of which is typically several meters thick. And each layer has coarse pyroclastic rocks in the lower part and finer grained rocks in the upper part, which are normally graded and consist of reworked pyroclastic fragments. So this is a montage of core sticks that shows what this layered character looks like. This is the deepest point of the core, and these deepest core sticks consist of fine, reworked pyroclastic fragments. So this is the top part of a layer. And about here is the boundary between two layers, where you can see there's an abrupt change in character. And then in these shallower core sticks, we're in coarse pyroclastic rocks forming the lower part of the layer above. And the coarse pyroclastic rocks are very distinctive. You can see in this more detailed photograph that they are lapilli tuff and lapilli stone, in which most of the fragments are formed of andesite. So these are volcanic rock fragments. And many of them are polygonal and concentrically zoned. So there's some good examples down here. You can see they have a polygonal character, very angular. And you can see the concentric zoning, dark green outer edges and paler cores. And all of these clasts, when you look at them closely, there's a good one there, another one there, have dark green rims and paler cores. And you often see fragments of dark grey mudstone and pale grey limestone mixed in with the andesite fragments. So back in this montage, the dark fragments, the dark patches, are fragments of mudstone. And a lot of the pale grey patches, like these ones here, are fragments of limestone. So our interpretation is that the Nanyang Member is the product of multiple underwater eruptions from a seafloor vent. And each time the magma erupted into the water, it chilled very rapidly. In other words, it was quenched. And that caused it to shatter into these sort of distinctive polygonal shapes, the outer surfaces of which then altered quickly in contact with the seawater to create the concentrically zoned appearance. And the mudstone and limestone fragments would have been entrained in the magma as it moved upwards through the Pulau Air Chawan Formation strata, which is the host unit. And then the finer grained, normally graded rocks at the top of each layer represent the smaller fragments that were erupted into water and then slowly settled through the water column before accumulating on top of the coarser pyroclastic rocks, which had accumulated more quickly at the base of the layer. So the Nanyang Member is very distinctive, and it should be quite easy to identify if you come across it in a core or even an outcrop. Now the Kent Ridge Member has a quite different character. It's essentially massive. In other words, it's not obviously layered, and it consists almost entirely of lapilli tuff. And in that lapilli tuff there are fiamme. So these dark green pieces are fiamme. They're essentially compressed fragments of volcanic glass or pumice. There are a lot of lithic fragments. So that here's an example here. These are fragments of volcanic rock that are picked up in the magma as it moves up through the volcanic edifice before eruption. There are a lot of small crystals and crystal fragments which give these rocks a bit of a speckled appearance. And all of these bits and pieces are enclosed in a matrix of fine ash, which is probably the dominant component in the rock. And you can see in these three examples that the appearance of the rock can vary quite a bit from place to place, but actually the actual composition and texture of the rocks, as far as we can tell, is pretty homogeneous right the way through the unit. And this variation in appearance is almost entirely due to the effects of alteration after the rocks were deposited. So the Kent Ridge Member is a classic pyroclastic flow deposit, sometimes known as an ignimbrite. And it's huge. This one deposit is more than 150 meters thick in places, and it's continuous over at least 10 kilometers of strike. So we think it's the product of a very large volcanic eruption that probably produced a large volcanic caldera, maybe several kilometres across, which is not preserved in the geological record now. And we've shown that the Kentridge Member has exactly the same age and chemical composition as the dairy farm Pluton in the Bukit Timah Centre. So we think the ignimbrite that produced the Kentridge Member was created by a huge eruption from the magma chamber of the dairy farm Pluton. And that eruption is what caused the sudden drop in pressure in the dairy farm magma chamber, which produced the Facies II rocks with the porphyritic or quenched character that I described earlier. Now, that eruption probably happened on shore, but the Kentridge Member is part of the Pandan Formation, which was deposited offshore. So we think the ignimbrite must have erupted onshore, then flowed offshore before it was deposited on the seafloor. And finally, the Clementi Member. Now, the pyroclastic rocks in this unit are also mainly lapilli tuff, but the unit is distinctive in a couple of ways. Firstly, it isn't a single thick unit of pyroclastic rock like the Nanyang Member and the Kent Ridge Member. It actually consists of multiple layers of pyroclastic rock, some of them getting up to about 16 metres thick. And in between these layers are interbedded layers of sandstone and mudstone. So it's actually a succession of interlayered pyroclastic rocks, sandstone and mudstone. And the second thing that makes the Clementi Member distinctive is that a lot of the pyroclastic rock has been substantially altered by soil forming processes. So these three photos, which are all from cores through the Clementi Member, show different stages of that process. In this one, the rock is relatively fresh, and you can still see a lot of the original texture of the lapilli tuff. In this one, the rock is moderately altered by pedogenesis, so it's starting to develop a reddish colour, and a lot of the original textural detail has been lost. And then in this one, the rock is very reddened, and there's virtually none of the original textural detail left. Now, this last photo is what a lot of the pyroclastic rocks in the Clementi Member look like now. It's essentially a fossilized soil, or paleosol. And as well as the distinctive reddish colour and the loss of original texture, you can sometimes also see small nodules of white calcrete and evidence of biological activity, like root traces, for example. So these are all features that commonly form as a result of pedogenesis, or soil forming processes. So we interpret this unit to have formed in an onshore environment during a time of repeated, relatively small volcanic eruptions that produced numerous relatively thin pyroclastic flow deposits interbedded with sedimentary rocks. So I'll finish with a quick recap of the key points. We now recognise 6 Plutons in Singapore. 5 of them formed during arc-related volcanism in the Permian and Triassic periods, and these are now grouped as the Bukit Timah Centre. The 6th is a small Cretaceous Pluton which is not related to the older Plutons. We now recognise 4 units that are dominated by pyroclastic rocks. 3 of them are part of the Jurong group succession, and they all formed during the same arc-related volcanism that produced the Bukit Timah Centre. Now, the pyroclastic rock units are quite distinctive and easy to tell apart, but the Plutons can be difficult to distinguish from each other. So remember to use all of the resources that are now available to help you identify the rock units that you see in cores and outcrops. So those are the new geological map, the memoir, a set of scientific papers, and the stratotypes that have been identified for all of the bedrock units. That's the end of this presentation. I hope you find it interesting, and thanks for listening.